Welcome to Beyond Earth, where we explore planetary science and the mysteries of the universe. Today, our journey takes us to a planet that once shook with unimaginable volcanic power. Mars. Mars is often called the Red Planet, but its surface tells a much deeper geological story. Today, Mars is a cold desert world. Temperatures can fall below negative 153 degrees Celsius or 225 degrees Fahrenheit, and its thin atmosphere offers little protection from radiation or extreme weather. But billions of years ago, Mars was a far more active planet. Volcanoes erupted across its surface. Lava flowed across enormous plains, and massive geological forces shaped the landscapes we see today. One region in particular stands above all others, a volcanic plateau known as Tharsis. The Tharsis region is home to some of the largest volcanoes in the solar system. Three enormous volcanoes, Olympus Mons, Mons, and Olympus Mons, stretch across the Martian surface like a chain of giants. But even these colossal mountains are overshadowed by something even larger, a volcano so vast it defies comparison: Olympus Mons. Olympus Mons is the largest volcano ever discovered in our solar system. From base to summit, it rises nearly 22 kilometers or 14 miles high. That is almost 3 times taller than Mount Everest. But its true scale becomes even more astonishing when you consider its width. Olympus Mons stretches more than 600 kilometers or 400 miles across. If placed on Earth, it would cover an area roughly the size of Arizona. Olympus Mons belongs to a type of volcano known as a shield volcano. Shield volcanoes form when extremely fluid lava spreads across the surface in wide sheets. Instead of building steep peaks, the lava flows outward over great distances before cooling. Each eruption leaves behind another thin layer of rock. Over time, these layers slowly stack on top of one another, creating a mountain with broad, gentle slopes. The lava that built Olympus Mons was most likely basaltic lava, similar to what erupts in places like Hawaii on Earth. Basaltic lava is relatively thin and runny compared to thicker magma. Because of this, it can travel vast distances before solidifying. Some lava flows on Mars may extend hundreds of kilometers from the volcano's summit. One of the biggest reasons Olympus Mons became so enormous is that Mars does not appear to have active plate tectonics. On Earth, the crust is divided into moving plates. As these plates shift across volcanic hotspots, new volcanoes form while older ones move away and become inactive. This is how volcanic chains like the Hawaiian Islands are created. But on Mars, the crust remained fixed above the same magma source for millions and possibly billions of years. This allowed Olympus Mons to continue erupting in the same place for an incredibly long time. Instead of forming a chain of volcanoes, Mars built one gigantic volcano. Olympus Mons grew so large for another important reason as well. Mars has much weaker gravity than Earth. The planet's gravity is only about 38% as strong as Earth's. With less gravity pulling material downward, volcanic mountains can grow far taller before their own weight causes them to collapse. This allowed Olympus Mons to reach heights that would be structurally impossible on Earth. Standing on the slopes of Olympus Mons would be a strange experience. The mountain is so enormous that its slopes rise at only a few degrees of incline. In fact, if you were standing on its surface, you might not even realize you were climbing a mountain at all. The volcano rises so gradually that its summit disappears over the curve of the Martian horizon. Around the base of Olympus Mons lies one of its most dramatic geological features, a massive escarpment cliff that surrounds much of the volcano. In some areas, this cliff rises nearly 8 kilometers or 5 miles high. Scientists believe this cliff formed as the enormous weight of the volcano caused the surrounding crust to sink and shift. This created a steep boundary where the massive volcanic structure meets the surrounding plains. At the summit of Olympus Mons lies a vast volcanic depression known as a caldera. But this is not a single crater. Instead, it is a complex system of overlapping collapse craters formed during ancient eruptions. As magma chambers beneath the volcano emptied, the ground above them collapsed inward. These collapses created enormous pits across the summit. Some of these calderas are dozens of kilometers wide, forming one of the largest volcanic summit structures in the solar system. Determining the exact age of Olympus Mons is difficult, but crater counts suggest the volcano began forming billions of years ago. Some lava flows may even be relatively young in geological terms, perhaps only a few million years old. In planetary geology, that is practically yesterday. This raises an interesting possibility. Olympus Mons may not be completely extinct. It could still be considered a dormant volcano, capable of erupting again someday. Today, Olympus Mons stands silent beneath the thin Martian sky, a monument to billions of years of volcanic activity. A mountain so large it reshaped the crust of an entire planet, and a reminder that even distant worlds hold extraordinary geological stories waiting to be explored. If you enjoyed this video, don't forget to like, subscribe, and leave a comment. It really does help the channel grow. Thanks for watching Beyond Earth.